In this video, we'll be looking at how to create structure charts. A structure chart is a diagram which helps us show the relationship between the modules and the subroutines. This plays an important role in connecting our data flow diagram logic to our algorithms or pseudocode flowcharts. The first thing you need to do is make sure you have a data flow diagram completed before you can start this section. There are symbols that you need to know. The first symbol is the hollowed out circle, which has an arrowhead, which represents a flow of data going in between modules. We have a solid arrowhead representing a flag or control variable. We have a right angled with a square inside it, which represents a option or decision point. And then we have a curved back arrow, which represents repetition, which means that routine will repeat more than one time. So if we look at the example provided, we have a school library system. You can see that we always, at the very top of the page, have the name of the program we're developing. And then you have your first level of subroutine. So we can see we've got borrowing and returning. And then connected to that, we have our subroutines. Now you can see right away that we have three levels of subroutines. We have the borrowing, returning. Then we have the second layer here, which includes validate student information, book information, update book and student files, checkbook, update files and reports. And then we have the layer which relies on checkbook of locate book record and check if overdue. You can see the flow of data with the solid arrowheads going between the subroutines, and you can see any control flags with the hollow ones. We also have arrowheads representing any loops or any repetition. And you can see under returning, we have an option there, which is the reports generation. In this example, we'll be looking at the fixed speed camera example that we'll be looking at in previous videos. Please download a copy of the data flow diagram before proceeding, and I would recommend printing it out, as this will become the basis of your structure chart. If we look at our data flow diagram, you can see we've identified 4 processes. We've also identified the relationship of any flags or variables that are going between those. Now, the best way to start a structure chart is always at the top of the page, you put down in a rectangle the name of the system. In this case here, it is fixed speed camera. Then you need to work out what is your first layer of subroutines. Now, most programs will be very flat with very little subroutines, but what you need to work out first is, are there any relationships between the processes that can only be completed first before moving on to the next subroutine. So you can see an example of our data flow diagram. Detect time of day is our top level. Then our next one is detect speed of vehicle, which means that we can only work out the speed of the vehicle based on what the time flag comes from the time of the day. Once we've worked out the speed of the vehicle, if they're infringing the speed limit, then we can send a speeding flag of speed to the next process. So that becomes our third layer, capture photo vehicle. So then lastly, we can only capture, once we've captured photo vehicle, we then can store the details. So this example is very specialized because we're going to have several subroutine layers. Most examples like the library routine will have more of a flat look. Now I do recommend that you practice these. So let's get started. So first thing we do at the top of the page is we have the fixed speed camera, and then we have a line connecting to the next process, which is detect time of day. Now from our data flow diagram, you can see we have a time flag, which is moves on to detect speed of vehicle. And we know we also have the speed. Here we can use a curved back arrow to represent that the time of day is always constantly being checked to feed in at the appropriate time. So for example, if it's 9 o'clock in the morning, it's a school zone. But we're going to be checking this regularly to work out whether it's a normal or special vehicle time. We then move on to the third process. So the second process, which is the detect speed of vehicle. We know that from that we have a speed flag and a photo vehicle. Notice how we're using the hollow arrows for data, and we're using the solid for any flags or Boolean values. It's really important. The next process we have is the capture the photo vehicle. And you can see there we get the speed flag, and we get the photo vehicle, and also speed. And then finally, we have the store vehicle details, and in there we have it should be a hollow arrow with the photo, speed, date, time, location of camera. Now, structure charts aren't the easiest things to develop, but they are an important bridge between our data flow diagrams and our algorithms. The process of these design tools is around abstraction. So we're taking a concept such as a fixed speed camera, and we are slowly breaking it down into easily smaller problems so we can work out what variables, what are our processor routines, subroutines, and basically we're taking it from a complex problem and we're simplifying it so we can program it. So I do recommend you download the attached sheet to this and try drawing a structure chart for the other two problems. If you have any questions, please let me know.